All right, let's talk about the supercomputer you're probably holding in your hand right now. We're going to trace its family tree all the way back to those giant brick phones from the 80s. It's an incredible story, really, and it's all about one generation's technology solving the problems of the one before it. So let's dive in. So, yeah, how did we get from phones that could only make calls to these things that, well, they run our entire lives, don't they? It's all about evolution. Each new G, each generation, was built on the successes and the failures of the last. To really get it, we've got to go back, way back, to the beginning. Okay, picture this. It's the 1980s, and we're talking about 1G, the very first generation. For the first time in human history, you could make a phone call without being physically tied to a wall. I mean, that was huge, a total game changer. But man, looking back, it was so basic. So the big word for 1G is analog. Think of it just like your car radio. It used analog radio waves, and that meant it could do one and only one thing: voice calls. That's it. No texts, no internet, nothing. The data speed, a whopping 2 kilobits per second, just crawling. And the system it used to handle calls, this thing called FDMA, well, let's just say it had some major flaws. Okay, this highway analogy is perfect for understanding FDMA. Imagine the airwaves are a giant highway. For your phone call, 1G give you your own private lane. Sounds great, right? But here's the catch. That lane was yours for the whole call. Even when you weren't talking, when there was just silence, that lane was still blocked off, totally empty. It was just a massive waste of space. And that inefficiency led to a whole bunch of problems. The voice quality was often terrible. There was absolutely zero security. Seriously, anyone with a basic radio scanner could just listen in on your calls. And because it wasted so much space, the capacity was super low. So yeah, a great first try, but the world quickly realized this just wasn't going to cut it. Something had to change. And that change came in the 90s. Enter 2G, the second generation. Now, this wasn't just a little step up. No way. This was a full-blown revolution, and it all came down to one single massive shift. Everything went digital. You know, just by turning voice into ones and zeros, 2G basically fixed all of 1G's problems in one shot. It brought in digital encryption, so for the very first time your calls were private. It used clever compression to squeeze way more calls onto the network, which was a huge deal for capacity. But the best part? It gave us something completely new, something that would change the world: the text message. Yep, SMS was born right here with 2G. I mean, when you put them side by side, it's really night and day, isn't it? 1G was analog, totally insecure, and super inefficient. 2G comes along and is digital, private, and way more dynamic. It could just handle so many more people, and it could do more stuff. It was a gigantic leap forward. But, 2G's story wasn't over. Once we had a taste of digital, we wanted more. We wanted data. So we got these, let's call them half steps. First, there was 2.5G, which used something called GPRS. This lets you do really basic stuff, like check your email or look at a super simple web page. Then came 2.75G, or EDGE, which, well, it just made things a tiny bit faster. We were officially on the path to the real mobile internet. And then, bam, we hit another wall. Look, 2G was awesome for texting and some light email, but it just wasn't built for the heavy stuff. Things like video? Forget about it. It was totally out of the question. The world was hungry for more data, and poor old 2G just couldn't keep up. So what's the answer? Well, it arrived in the early 2000s, and it was called 3G. Now, this is the generation that really, truly put the internet into our pockets. It wasn't a patch or an upgrade. It was built from the ground up specifically for data. And boy, did it change everything. So yeah, the speed jumped up to 2 megabits per second, which was great. But the real genius of 3G was a clever trick called packet switching. Remember that dedicated highway lane from 1G? Packet switching got rid of that. Instead, it chopped your data into tiny little packets and sent them out into traffic to find the most efficient route. It was so much smarter and more efficient, and that's what made things like real web browsing, video calls, and even mobile TV possible for the first time. And what happened next? A whole new world opened up, an entire ecosystem. Thanks to 3G, our phones went from being just phones to being these powerful multimedia gadgets. We're talking online shopping, maps and navigation, watching videos whenever you want. you could make a pretty strong case that the whole app economy really started right here. Okay, 3G was fantastic, but you know how it goes? We always want more. Our hunger for high-def video and really powerful data-heavy apps just grew and grew, and 3G started to feel the pressure. It started to lag. The solution? It showed up around 2010, and it was called 4G, the generation that basically created the modern mobile world we live in today. And if 4G was about one thing, it was speed. Speed. This wasn't just a little bit faster, this was a mind-blowing exponential leap. We're talking going from a maximum of, 2 megabits on 3G to a potential of 1 times gigabit per second on 4G. Do the math. That's a 500 times increase. It's just insane. So how on earth did they do that? Well, they basically threw out the old designs and started fresh. 4G was built on what's called an all-IP core. All that means is that the network itself was designed to speak the native language of the internet. You combine that with some really slick antenna technology called MIMO, which is just a fancy way of saying it uses multiple signals at once to make things faster and more reliable, and suddenly you've got the power for silky smooth HD streaming and legit online gaming on your phone. Yeah, this chart really lays it all out. Just look at the insane jump in data speeds. And the move to a packet-only system, where the entire network is basically the internet. 4G wasn't just an upgrade. It completely redefined what a mobile network could even do. And that brings us right up to today, to 5G. Now look, it's really tempting to just think of 5G as 4G but faster. And sure, it is faster, but that's really missing the big picture. 5G is a totally different beast. It was designed for a future where it's not just about connecting you and me, it's about connecting, everything. Really, 5G is built on 3 main ideas. Pillar 1, insane speeds, great for stuff like VR. Pillar 2 is something called ultra-low latency. Latency is just the lag, the delay between you doing something and the network responding. With 5G, that delay is almost zero, which is what you need for crazy stuff like remote surgery or self-driving cars. And Pillar 3, massive connectivity, the power to connect billions and billions of little devices all at once. That's the Internet of Things, or IoT. So to pull all this off, 5G needs a different kind of setup. It still uses the big cell towers you're used to seeing, for broad coverage, but it adds these little clusters of small cells. You can think of them like powerful short-range Wi-Fi hotspots that deliver those insane speeds, which makes them perfect for crowded places like city centers or stadiums. Whew. Okay, that was a lot, right? We've gone from simple analog phone calls all the way to a world where everything's connected. So let's just take a step back and look at the whole journey, all at once. This table just lays it out so perfectly. You can see the pattern, right? Every decade or so, a new generation comes along. It brings a new core technology, and it enables some new killer service. We went from voice to SMS texting to real mobile data to high-def streaming, and now, with 5G, we're in the age of the Internet of Things and AI. When you boil it all down, this whole story is about one thing: solving problems. 1G had bad quality and no security. 2G comes in and fixes it with digital. 2G couldn't handle data. 3G comes along and solves that. 3G wasn't fast enough for streaming Netflix. 4G delivered. And 4G wasn't built for a world of billions of connected devices. Well, that's exactly the problem that 5G is built to solve. And that really leaves us with one final fascinating question. We've seen that every single generation was created to fix the shortcomings of the one before it. So as 5G starts connecting our world in ways we can barely even imagine right now, what new problems are we going to create? What is the big challenge that 6G is going to have to solve? Something to think about. Thanks for joining me.